My name is Tawfiq Omar Uthman, math teacher. Today I will explain Chapter 2, Lesson 2, Part A, Finding Limit. Please do not forget to subscribe the page and press the like button and write your comment and your question if you have. In this video, we are explaining how to find the limits. In the first lesson, we explained to how finding the limit using graph. And now today we will take the rules of finding the limit. Finding limit. To find limit, replace the value which x approach to, we get three cases of answers. The first case, A, limit exists if the result was a real number. That means after replacing the value of fx, the result is a real number. The second case, limits that fail to exist if the result is such as number over 0 or square root of negative number. The third case is undetermined form like 0 over 0 or infinity over infinity. Then maybe the limit exists and we must search for it. Let us take the first case, limit exists. To find limit, when limit is exist, we must take some rules for finding limits. The first one, constant function rules. That means if the function is a constant function. If fx is a, where a is constant number, then limit fx when x approach to c is equal a. That means the constant stay as it is or result the constant same. For example, limit 5 when x approach to 2 is 5 because 5 is constant. And limit of minus 8 when x approach to 1 is minus 8. And limit when x approach to minus 3 for 1 over 3 is 1 over 3. The second rule is parent linear function rules. If fx is equal to x, then limit when x approach to c for fx is c. As you can see, we replace it c in place of x. It becomes c. For example, limit when x approach to 2 for x is 2. Replace 2 in place of x. Limit when x approach to 1 for x is 1. Limit when x approach to minus 1 for x is minus 1. Power function rules. If fx is x to the power n, then limit when for fx when x approach to c is equal c power n. As you can see, we replace it c in place of x, or we write it c instead of x. For example, limit for x squared when x approach to 2 is 2 square, which equal 4. Limit when x approach to 1 for x cube is 1 cube, which is 1. Limit when x approach to minus 3 for x to the power 4 is minus 3 to the power 4, which equal 81. Radical function rules. If fx is equal square root of x, then limit of fx when h approach to c is square root of c. Here too, we replace it c in place of x. Like limit of square root of x when x approach to 4 is square root of 4. Square root of 4 is 2. Limit when x approach to 1 for square root of x is equal 1. Limit for square root of x when x approach to 4 over 3 is square root of 4 over 3. Square root of 4 is 2 and square root of 3 is remain as it. Scalar multiply rule. If limit for fx when x approach to c is equal L exists, then limit of x approach to c for afx exists too, where a is a real number, and limit when x approach to c for afx is equal a limit x approach to c for fx, which equal al. Here we can see if we have a constant inside the limit, we can take this constant out of the limit, and then take a limit for the function. For example, limit for 3x when x approach to 2 is equal 3, we take it 3 to the outside of the limit and write the limit of x approach to t for x. And to find the limit, replacing 2 in place of x, it becomes 3 times 2 is equal 6. Or when limit is x approach to minus 1 for minus 2x cubed, we must first of all write minus 2, then replacing minus 1 in place of x, it becomes minus 1 cube. Minus 1 cube is minus 1. Minus 1 times minus 2 is 2. Limit when x approach to minus 3 for 1 over 3 times x to the power 4 is equal 1 over 3 times replacing minus 3 in place of x, it becomes minus 3 to the power 4. Therefore, minus 3 to the power 4 is 81 over 3, which equal 27. Some rules. If the limit fx for fx when x approach to c is equal L and limit for x approach to c for gx is k exists, then limit of x approach to c for fx plus gx is equal L plus k. Example, if limit when x approach to c for fx is equal 6 and limit for x approach to c for gx is minus 4, find limit when x approach to c for fx plus gx. Solution: limit of x approach to c for fx plus gx is equal 6 plus minus 4. 6 plus minus 4, which equal 2. Example: if limit for x approach to c for fx is 12 and limit x approach to c for fx plus gx is equal minus 5, find limit when x approach to c for gx. We know that the limit when x approach to c for fx plus gx is equal limit of x approach to c for fx plus limit x approach to c for gx is equal. We have this limit minus 5, replace it, and we have this limit 2, which is 12, and replace it and write plus limit when x approach to c gx. And now take 12 from right to the left, and it become limit when x approach to c gx is equal minus 5 minus 12, which is minus 17. Difference rule. If the limit x approach to c for fx is equal L and limit when x approach to c for gx is equal k exist, then limit when x approach to c for fx minus gx is equal L minus k. L minus k. For example, limit x approach to c for fx is 7 and limit x approach to c for gx is minus 9. Find limit x approach to c for fx minus gx. Limit when x approach to c fx minus gx is equal 7 minus minus 9 minus negative 9, which equal 16. Another example, if limit x approach to c for fx is 5 and limit when x approach to c for fx minus gx is minus 5, find limit when x approach to c for gx. Limit when x approach to c for fx minus gx is equal limit when x approach to c for fx minus limit when x approach to c for gx. Replacing the value, we have this limit is equal minus 5, replacing, and we have this limit is equal to 5 and replacing, it become minus 5 equal 5 minus limit x approach to c for gx. And now take limit x approach to c from right to the left and minus 5 from left to the right. It become limit when x approach to c for gx is equal 5 plus 5, which is 10. Product rules. If the limit x approach to c for fx is L and limit when x approach to c for gx is equal k exists, then limit when x approach to c for fx times gx is L times k, or multiplying these two numbers. For example, if limit x approach to c for fx is equal minus 3 and limit when x approach to c for gx is equal 2, find limit when x approach to c for fx times gx. Limit when x approach to c for fx times gx is equal lk. Therefore, minus 3 times 2, minus 3 times 2, it becomes minus 6. And if we have limit when x is approach to c for fx equal 5 and limit when x approach to c for fx times gx is 15, find limit x approach to c for gx. We have the rule that the limit when x approach to c fx times gx is equal limit of fx times limit of gx. We have this limit is equal 15, replace it, and we have this limit is equal and replace it. It become limit when x approach to c for fx times limit x approach to c for gx is equal 15. Then we have 5 here. 5 limit x approach to c for gx is equal 15. Dividing by 5, then limit of x approach to c for gx is 3. Another example, if limit fx x approach to c is equal minus 3 over 4 and limit when x approach to c for gx is 2 over 3, then limit of x approach to c for fx times gx is equal a, b, c, and d. Solution: limit of x approach to c for fx times gx is equal limit when x approach to c for fx times limit when x approach to c for gx, which equal this limit is minus 3 over 4 and this one is 2 over 3, cancelling 3 with 3 and 2 with 4, it remains minus 1 over 2. That means C is a correct answer. Example, if limit x approach to c for fx is equal minus 3 over 4 and limit when x approach to c for gx equal 2 over 3, then limit x approach to c for fx plus 2 times gx is equal a, b, c, and d. Solution: limit when x approach to c fx plus 2gx is equal limit when x approach to c for fx plus 2 times limit x approach to c for gx, which equal this limit is minus 3 over 4 plus 2 times this limit is 2 over 3, replacing, and become 2 times 2 is 4, there minus 3 over 4 plus 4 over 3 is equal 4 times 3 is 12, 3 times minus 3 is minus 9, and plus 4 times 4 is 16. That means 7 over 12. Polynomial function rules. If fx is a polynomial function, then limit for fx when x approach c is equal fc. That means we are replacing the value of c in place of x. Example, find limits when x approach to 2 for fx when fx is equal minus 2 x to the power 5 plus 3 square x square minus 7 x plus 5. Limit x approach to 2 for fx is equal f of 2 because this function is an polynomial function. Therefore, it becomes minus 2 to the power 5 plus 3 times 2 square minus 7 times 2 plus 5 is equal minus 64 plus 12 minus 14 plus 5, which equal minus 61. Find limit when x approach to 2 for fx when fx is 3x to the power 5 minus 2x cubed minus 4x squared minus 3. Limit when x approach to 2 fx is equal f2. That means replace 2 in place of x. It becomes 3 times 2 to the power 5 minus 2 times 2 cubed minus 7 times 2 square minus 2 is become 61. Division rules. If the limit fx x approach to c is equal to L and limit gx x approach to c is k exists, and if limit gx for x approach to c not equal to 0, then limit when x approach to c for fx over gx, it is limit for fx over limit for gx when x approach to c, it equal L over k. Example, find limit when x approach to 2 for fx, where fx is equal x squared minus 1 over x minus 3. Limit when x approach to 2 for fx is equal limit when x approach to 2 for x squared minus 1 over x minus 3, and write the limit for denominator and numerator. Limit when x approach to 2 for x squared minus 1 over limit when x approach to 2 for x minus 3. It become, replacing 2 in place of x, it become 2 squared minus 1 over 2 minus 3. It equal minus 3. We can solve this example directly by replacing 2 in place of x in the fraction. That means we start here 2 square minus 1, 2 minus 3, without writing these steps. Example, find limit when x approach to 2 for fx, where fx is equal x plus 2, x minus 1. Limit when x approach to 2 for x plus 2 over x minus 1 is equal. Replacing 2 here, 2 is 2 plus 2 and 2 minus 1, it equal 4 over 1, which is 4. Composite function rule. If the limits x approach to c for gx is L and limit of x approach to L, this result for fx exists, then limit of x approach to c for f gx is equal to f of limit when x approach to c for gx, which equal f of L. Example, we solving this equation in two ways. We can do it as the rule is say, or replacing directly. We are replacing directly. Limit when x approach to 2 for fx is equal square root of 2 square plus 4. It becomes square root of 8, which is equal to square root 2. Find limit when x approach to 2 for fx, where fx is square root of x cubed minus 4. Replacing 2, it becomes square root of 2 cubed minus 4, which is equal 8 minus 4 is 4, then square root of 4 is 2. Another example, find limit when x approach to 2 for f of gx, where fx is x squared plus 4 and gx is square root of x. First of all, we have two ways to solve this example. The first one, find the function f of gx, which equal f of gx. We have gx square root, replacing in place of x, it become f of square root of x. It become square root of x squared plus 4, which equal x plus 4. And now we can find the limit. Limit of x approach to 2 for f of gx is equal f of g2, which equal square root 2 square 2 plus 4, which equal 2 plus 4 is equal 6. We can do this in another way. Because we have the first one, this one, gx, then replace these two in gx and find g of 2 and find g of 2. Therefore, g of 2, replacing 2 in place of x, it becomes square root of 2. After that, replace this value, this result, in fx. It becomes f of square root of 2, which equal square root of 2 square plus 4 is equal 2 plus 4, which equals 6. This is another way. Example, if fx is equal x cubed plus 2x minus 1 and gx is equal 1 over x minus 4, then limit when x approach to 1 for g of fx equal a, b, c, and d. We can, because we have an fx here before, replace 1 in fx and the result replace it in gx. Find f1, it become 1 cube plus 2 times 1 minus 1, which equal 2, because this one cancelling with this one became 2 times 1 is 2. And now find g of 2. G of 2. G of 2 is equal 1 over 2 minus 4 is equal minus 1 over 2. That means limit when x approach to 1 for g of f, x is equal minus 1 over 2. The D is a correct answer. If fx is ax minus 4 and limit of x approach to minus 1, gx is equal 4. If limit when x approach to minus 1 for f of gx is equal minus 3, then a is equal a, b, c, and d. We have limit when x approach to minus 1 for f of g is equal minus 3. And now limit when x approach to minus 1 is equal f of gx, which equal minus 3. And taking limit to inside, then f is equal limit when x approach to minus 1 for gx, which equal this, we have this limit is equal to 4 and replace it, then become f of 4, which equal minus 3. And now replace 4 in fx. It become a times 4 minus 5 is equal minus 3. Then 4a is equal, taking minus 5 from left to right, it become minus 3 plus 5. Then 4a is equal 2, and dividing by 2, a is equal 1 over 2. We have a fast way to solve this example, which replace x in fx, replace 4 in fx. It become a4 minus 5, or find f4. First of all, find f4. Because we have g first, then g is become inside of the f. Then 4a minus 5 is equal this number. Placing 4 here and equaling to minus 3. We get this solution. Limit when x approach to c for sine x is equal sine c. That means replacing c in place of x. And limit when x approach to c for cosine x is cosine c. And limit when x approach to c for tangent x is tangent c. In the condition c not equal pi over 2 plus k pi, or limit of x c cosine x not equal to 0. Example, find limit when x approach to pi fx, where fx is x cosine x. Limit when x approach to pi for fx is replacing pi in place of x. It become pi cosine pi. Cosine pi is minus 1, then the result is minus pi. Example, find limit when x approach to pi over 2 fx, where fx is x cosine x. Limit when fx x approach to pi over 2 is equal pi over 2 cosine pi over 2. Pi over 2 cosine over pi over 2 is 0, therefore the limit is 0. Rules for the natural exponential function. Limit when x approach to c, e to the power x is equal e to the power c. That means we replace it c in place of x. And rules for the natural logarithmic function. Limit when x approach to c for ln x is ln c. Again, we replace it c in place of x. Example, find limit when x approach to pi for fx, where fx is 3e to the power sine x. Limit when x approach to pi for fx is equal 3, replace pi in place of x, it becomes 3e sine pi. Sine pi is 0, then 3e to the power 0. E to the power 0 is 1, then 1 times 3 is 3. Example, find limit when x approach to 0 fx, where fx is 3 ln x plus 1. And now replace 0 in place of x. Therefore, limit when x approach to 0 for fx is equal 3 ln 0 plus 1. 0 plus 1 is 1. Ln of 1 is 0. Therefore, 3 times 0 is 0. Here we came of the end of the video. Thank you for watching, and please do not forget to subscribe the page and share it with your friends so that everyone will benefit and get each new video. Write your comment and press like. Thank you.